Good day to all. Today our topic is unary diagram or single component phase diagram. In previous video we discussed about what is meant by crystal structure and what is meant by phase diagram. Likewise we discussed. Today we go into the content of unary diagram or single component phase diagram. Unary diagram always concentrated about single component for explaining its variations with the pressure and temperature variations with its state. So it has a diagram as like this. In that diagram there is invariant equilibrium, univariant equilibrium and bivariant equilibrium are available. Before going into understand the thing related with invariant, univariant and bivariant equilibrium, you should aware about what is meant by phase rule. Already in previous video we discussed about phase rule. Again I tell you, phase rule is small f is equal to small c minus p plus 2. Here phi is number of independent variable, which is another name called as degrees of freedom, and small c is number of component and p is number of stable phases in the system. Here I can show you the diagram of unary unary phase diagram, which composes with the temperature and the pressure. The temperature in x-axis and the pressure with the y-axis. We can draw the three curves, which is 1, 2, 3, and the 3 curve ended with 4. Likewise, we can draw the curves. These 3 curves are the separate the phases available with this graphical area. The area below the curve with 1 and 4 is called as gaseous state, and in between 1 and 2 called as the solid phase, and the space in between 2 and 3 is the liquid phase. So every material has 3 phases, which are gaseous, liquidous and solidus state. Here we can explain the 3 stages, 3 states with this pressure temperature diagram. Okay, so here stable equilibrium. Already we know about the equilibrium according to our previous video. Here what is equilibrium, which is the next question. Equilibrium has 3 stages. One is stable, second one is metastable, and the third one is unstable. Stable is object is in lowest energy state, and metastable, second one in metastable is additional energy is required to getting the stable condition of material atoms, and also it can be achieved through rapid cooling and or freezing of unstable thermodynamic structures like glass material. And unstable, which is the third equilibrium condition, unstable, here which is not needed of additional energy, that particle entering into stable or metastable conditions, which is known as equilibrium. The equilibrium also has its subdividend, which are invariant equilibrium, univariant equilibrium, bivariant equilibrium. We can classify with the phase rule. In that, what is invariant equilibrium? Invariant equilibrium can be explained with the phase rule as like small f is equal to 1 minus 3 plus 2 is equal to 0. Here 1 is number of independent variable, degrees of freedom is to be found with the number of component as 1 and the number of stable phases as 2. Here the invariant equilibrium is explained with the stable equilibrium. So the point, the junction point of 1, 2, 3 lines or curves is joined with the intersection. That intersection point is called as a triple point. The triple point means the 3 phases occurred at the same point, so that point is called the triple point, where the 3 boundaries are intersect. This point is called as a triple point also. This point also is called an invariant point because at that location on the diagram, at externally controllable factors are fixed. The number of degrees of freedom is fixed. Okay, number of degrees of freedom fixed, and then at this point all the 3 states phases, which is liquidus, solid, gas, are in equilibrium, but any changes in pressure and or temperature will cause 1 or 2 of these states to disappear. So the invariant equilibrium is important in unary diagram at a triple point. And then univariant equilibrium. Univariant equilibrium can be explained with the f. Okay, number of independent variable is equal to number of component 1 minus number of stable phase as 2 plus 2. So likewise we can represent univariant equilibrium, which is based on either pressure or temperature, maybe freely, but not both. Once a pressure is selected, there is only one temperature that will satisfy equilibrium conditions. And conversely, the three curves that 1 and 2, 3 that issue from the triple point are called triple curves. Line 1 representing reaction between the solid and the gas phases is the sublimation curve, and the line 2 is the melting curve, and the line 3 is called as vaporization curve. The vaporization curve ends at point 4, called as a critical point. So here the fourth one is called as critical point, where the physical distinction between the liquid and the gas phases disappear. So the fourth point, the liquid and the gas phases disappears. So then the bivariant equilibrium can be studied with the number of stable phases. So okay, here P is equal to 1 minus 2 plus 2. From this phase rule we can study bivariant equilibrium. If both the pressure and temperature in a unary system are freely and arbitrarily selected, the situation corresponds to having 2 degrees of freedom, and the phase rule says that only one phase can exist in stable equilibrium. This situation is called as bivariant equilibrium. So these are all the conditions, equilibrium conditions are available with the unary diagram. Next video we should discuss about the binary diagram, what all the thermodynamics characteristics are associated with the material science with pressure and temperature curve. Thank you all.